Hello, everyone. Welcome to the Data Science Mentor Program and the Data Science Mentor Session. And today we are going to be doing a follow-up from our last session, which is an introduction to decision trees and random forests. My name is Pablo. I am a host, founder, and convener of the Data Science Mentor Cohort and Program, an accelerated learning program for anyone picking data science from scratch. Right. So what are we going to do today? If you look on the screen, you would notice that there are a bunch of stuff on the screen. And what I meant was we used in our last session we introduced random forest and decision trees, and today we're going to look at, we're typically going to talk about overfitting. But in this first part of talking about overfitting, it's typically important. Yeah, I think it's radically important that we sort of understand what goes on when overfitting happens. So this is basically overfitting part one, right? So what we're going to do in this session is we're going to, write a function that will help us visualize what's happening on our screen over here, right? Okay, I think what I'll do, I'll just get my annotator. Here we go. So you can see that a bunch of things are happening inside here. We can see some stuff going on here. Now, what we're going to do is we'll write a function, and the function is going to let us see, okay, what goes on if we have a model and what the model should do, right? So I think, let me see if we have, it's important. Yes, we're going to do that. So that's what we'll do. Now, the first thing we will do is to import the model class, right? Which is typically the steps we ought to follow. So I'll start off by saying from sklearn.tree, we import the decision tree classifier. So this is what this is, right? The next step is we are going to create a decision tree, and we're going to fit it to this blob that we have created here, which is the X and Y. Now, it's a very simple stuff we're going to do. We're going to call this, what do we call this? Okay, we'll call this the tree model. So we'll call this the tree underscore model. Now, inside here, I'll call on the decision tree classifier. Then I'll fit this blob that has this data here in it. And so which is going to be X and Y. Again, X and Y is a representation of a feature matrix and target vectors. Yeah. Now I feed this in and I run this model. So you see, basically, this is now here. The model is in here. Now, the next thing we want to see is we want to visualize how this was classified. So this is the first part to understanding our decision tree, and then going on to see what does it mean when it overfits. Right. So what I will do is I'm going to create this. I'm going to create this this function. It's a utility function, and what the utility function will do is to just help us visualize stuff. Right. So I'll start. I'll call this the utility function for visualizing the classifier. Yes, so it's a utility function for visualizing the classifier. That's what we're going to create right now. So I just encourage you to work, just see as we have the walkthrough here. Now, just to be sure if we have imported, yes, I think we already have this. We have this. We've gotten this. So we're going to be making use of a lot of stuff. Now, first things first, we are going to name our the classifier. So I'm going to call this V's underscore classifier. So I'll define this as V's underscore classify or V's underscore classifier. Now, what will this function have hold? Model, that's one. That's going to take our historical data, which is our independent variables. It's going to take our targets, and by default, we're going to have an object. We're going to have an object. By default, we're going to have an object for our axis. Then, again, by default, we're going to have our color map. And I think we should use the rainbow color map here. Right, so I think this works. Next, axis is going to be X, or is going to get us our axis. It's going to get us our current axis whenever we want it. Then next, we're going to plot the training points. Now, remember, the points are going to be these data points we have here. So it's basically these two things we're going to plot. And yeah, basically these two things we're going to plot, and we're then going to determine how they're going to look, the size, and obviously the color maps we have. So here, let's put some space here and then say plotting the training points. Now we would say x.scatter. Now inside here, what we're going to have is we're going to have our independent features. That's one. And we're going to have it in two ways. We're going to have it because it's going to be sort of broken down into different classes. So that's what I'm going to have here. So I have the two over here, right? In here, I would slice it. So we have the first one, and we have a second one here. Next, we're going to ensure that we classify them based on the targets. Right. Next, we're going to have them. We'll try to do a breakdown of this size. We'll just reduce the size a bit, make it 30, because this makes it's preferable when it is smaller, because we can now see the two the broken down points of this free model. Then finally, we'll have CMap, and CMap is going to be our default here, so this is going to be CMap. That's where it's going to be. Right. Any other thing? Okay, we have, let's say, the C limits, and what we're going to do is our limit is going to be between our target vectors minimum and our target vectors maximum. Then let's see. I think that's the. Or we can also set up an order. Yeah, so we have an order for me. Maybe want to break them down into 3 areas or 3 or 4 areas. No, that's not what it is. We'll have this broken down later. Next, we will have our axis. Now, if you've learned, if you've done introduction to data visualization with Matplotlib, you will understand that when we build an axis, we can determine if the axis, how do we want the axis to be. Do we want it to be equal? Do we want it to be to a certain place? Or we want it to be tight? So we're going to set the axis to tight. Now, if you're surprised at this, then I think you should go and take your introduction to data visualization for the data science mentor program. Then we have axis, axis. Now, here we're going to set it tight, and also, which means everything that is inside the axis is going to be tight. But if we have anything outside of it, we just want to basically ensure that our visual makes some sense. Now, the next we're going to go to our x-axis limits. And in our x-axis limit, we're going to say ax dot get underscore x limits. So that's what we're going to have here. Then we're also going to do the same for y lim, which is going to be ax dot get underscore y limits. All right. Now, the next thing we want to do is our model. Our model needed already, right? And what we will try to do is a model has been created, and we'll try to set up a model first off, right? And then once we set up the model, we will now put it sort of like in a grid and then see how it works in different ways. Then we'll go on to make a prediction, right? When we're now going to make a prediction, then we'll visualize it and visualize how it performs. Right, so that's one. So what we're going to do is we are going to fit our estimators. So model, which is basically going to be this model dot fit, and with model dot fit here, we will have x, y, then we'll have x, y, y, and here what we're going to do, we're going to say np dot mesh grid, and inside we are going to say np dot lean space, and our interest is going to be our x lim, and also the num is going to be 200. Also, the next stuff we want to look at is np dot lean space, because we would have both. we're going to have for our y, we're going to have for our y limb, and the num is also going to be 200. So you can now see that we're sort of setting up for like our x and y, what's going on in terms of our limits. Right. Then I'll introduce z here. Now, what z is going to be? Z is going to be our model dot predict. And model dot predict, what we're going to have is we are going to say np dot c. Yes. So basically, this is going to be for one class of model that we're going to be working with. So it's going to return a bunch of things. Now, what is it going to return? It's going to look at these guys, and we're going to flatten them. That's one. Then the same thing, yy dot ravel flatten. Right. I think that's works. Then we'll close. And then we close. Then we'll reshape whatever is in here to be whatever we bring out from here, because it's important. So we're going to have whatever shape is here, which is basically a mesh filled with 200 features. Next is we are going to create a color plot. So we have a color plot with the results, and I mean that's basically important so that it looks good when we visualize them. So here is the color plots. Now with the color plots, I'm going to n underscore classes, and here I'm going to look at the total number of np.unique of whatever unique classification came out of the predictions, right? And then on pause. So if we have contours, we're going to look into our ax.contours. And what we're going to use for our contours, which we will break them through, is going to be xx, yy. Our prediction over here is z. We want it to have some form of transparency, 0.3. Any other thing we create levels, and levels is going to be np.a range, np.a range. Now np.a range will take n underscore classes plus 1 and subtract 0.5 from it, which basically would sort of give spaces when we're looking at our contours and all. What else? CMAP colors will be equals to CMAP. We've already defined that at the beginning as rainbows. And we have Z other equals to 1. Then the final part of it sets ax.sets. What are we going to set? We're going to set our x limb, which is going to be as x limb. We're going to set our y limb, which is going to be our y limb. So we're going to run this. Now we now have 5, right? I hope there's nothing we're missing. Now, again, remember, we're trying to classify these guys, and we're going to use the model to do the classification, just like what goes on in here, just to visualize that. Then I'm going to say this classifier. Now, with this classifier, what I'm going to take this same, we're going to take this decision tree here. Then we are going to, which is the model. Remember, first, this is the model. It takes a model. If we don't, we take a model and we will put X, comma, Y. And for that, we're all going to, right, because we've created. So we run this. Right. Okay, let me see. PLT.show. Yeah, look at that. Not so cool, but I mean, you can see that some classification has happened here. Let me make this a little so that we can see. So you can see some classification has happened. These guys have all been classified in a way. Now, how is this decision making this decision, right? How is it even making this decision? I'd have wished they were able to put these rainbow colors at their back. It makes some sense. Was there anything I missed during the visuals? Get current access, paste this to Y. We give them the colors. No, I wonder what it is I have missed. All right, guys, can I just give me a second? I'm back. All right, guys. So we can see that we have some of this. I think what I can do later on for folks who have access to the notebook is to understand why maybe these colors, we didn't have specific colors. It must just be something I did not get correctly. Maybe I didn't. And then I'll just correct so you basically see. But you can see that this is a decision tree, the visualization of the classifier. Now, the next question we have to ask is, so how how does it overfit? That's the next question. How does it overfit? And it's really, really interesting that, you know, we try to make sense of the idea of overfitting. Now, typically, and this is the part, that's the last part of put in the explanation of overfitting. So the next question is, and I make this pretty close. Next question is to ask, what is overfitting in this scenario? Is overfitting, but at this point you already know what it is. But what is overfitting? Just for for those watching this for the first time, what is overfitting? So typically, overfitting is when a model memorizes the data instead of learning the patterns. Just think about it like studying for an exam. You memorize your practice questions, but instead of understanding, the patterns, why is this happening? It's like a pretty good example was in 2020. I started to learn cloud, the cloud infrastructure using the Google Cloud platform. But every time I took my labs, I just wanted to finish the lab. I just wanted to memorize the labs. But the reality was, if I needed to understand or become really good at it, I needed to, figure out if there was a pattern to solving the problem. And this happens most times. We just repeat stuff, and when you repeat stuff, you don't learn what it's about. It's just, consistent repetition. Yeah. So instead of looking for patterns, you typically just, memorize everything. And that's what happens. So then the question is, why? The next question is, why would a decision tree model overfit? Why? So because this will be a problem. So the question is, why does the decision tree model overfit? Yes. Now we have to look at a few. One of the things that happen when we are splitting this point, you see, is because it's basically asking questions, right? And if there are too many splits, then it will keep going until it's perfect. So one of the reasons is having too many splits. It goes until it's sort of like a drive or a split for perfection. So that's one of the issues you could have, right? Sometimes there are no limits, right? So here, what we could call is minimal. It has minimal constraints, right? So here, what it means here is, no limits set. So whenever there are no limits set, and one of the biggest things when you're setting limits is the max underscore depth. If there are no limits sets, right, the trees will just grow endlessly, right? And then because we're asking questions, right, because we're asking so many questions, the model will learn noise. When it learns noise, it will learn noise over signal. So the trees may learn rare or random quirks. So random quirks, and once it figures that, it just starts to act in a way that is different. So the next thing we want to look at is, so the next part of what we're going to be, and why a decision. So again, just to close up, part of the problems, part of the things you would often see is when you ask too many questions for the situation. If maybe you're creating a product and you already have like the first principles are laid out for your product and the problems you're trying to solve, you start to ask so many questions. You get to a point where your product will overfit, your product idea will overfit, even when you're trying to execute, and you start to ask too many questions. Sometimes you typically want to test and see and get the results and see what it is and then work with that. So that's a situation. This is basically like a first principle of what you're learning. And when it comes to the first principles of what the model is about, and then the situation, right, that makes the model overfit. So in our next session, we're going to look at what model overfitting is and looks like. All right, you have questions, you feel free to share. And or if you're watching the session, then you drop a question or questions in our private Telegram group for the Data Science Mentor Program. All right.